Hi everybody, in this video let's look at permutation and combination. But I will just focus on permutation first in this video, but I'm going to discuss with you when do we use permutation and when do we use combination. For permutation, the order of arrangement is important. Whereas for combination, the order of arrangement is not important. Okay, let me give you one example for each of them. Let's say if you have 4 digits, 1, 2, 3, 4. I want you to use 2 of them to form a 2-digit code. First time, you pick 2 first, then followed by 1. Second time, you pick 1 first, followed by 2. Are these 2 the same code? You know the answer. They are different code, right? So in this situation, the order of arrangement is important. We are going to use permutation to solve this type of question. So how about this? Let's say I have 4 students named Andy, Belson, Carson, and the last one just let it be Daniel. I want you to pick 2 of them to form a team which consists of 2 students. First time, you pick Andy, then followed by Daniel. Second time, you pick Daniel first, followed by Andy. Try to think, are these 2 the same team? Yes, right? Andy partner with Daniel or Daniel partner with Andy, they actually form the same team. In this situation, the order of arrangement is not important. We are going to use combination to solve this type of question. Okay, before I show you some example on permutation, let's look at this guy first. N factorial. What does this mean? N factorial. N factorial is just defined as n times n minus 1 times n minus 2 times n minus 3. Keep on multiplying until you reach 1. This might look a little bit complicated, right? Let me give you some example. Let's say I have 6 factorial. What does this mean? It just means that 6 times 5 times 4 times 2 times, after 4 should be 3 times 3 times 2 times 1. 6 factorial beginning from 6, keep on multiplying and the number keep on reducing by 1. 5, 4, 3, 2, 1. Okay, so this is 6 factorial. How about 5 factorial? It just means that 5 times 4 times 3 times 2 times 1. 4 factorial, I think you know the answer. 4 times 3 times 2 times 1, and so on. 1 factorial is actually equal to 1. Okay, now you look at this. 6 factorial, we also can write 6, I write over here, 6 factorial. We also can write 6 times 5, 4, 3, 2, 1 here. It's actually 5 factorial, right? I can write like this. They're actually the same thing. If you don't want to write this way, we also can write 6 times 5 times 4 times 3 times 2 times 1, which is equal to 4 factorial, right? And so on. Okay, now we just focus on this one first because later on I'm going to use this to show you that why is the 0 factorial is equal to 1. Six factorial is equal to 6 times 5 factorial. So 5 factorial is equal to 5 times 4 factorial. How about 4 factorial? is actually equal to 4 times 3 factorial. Okay, from here we actually know that n factorial is actually equal to n times n minus 1 factorial. Okay, now this one you need to be more careful. 0 factorial is not equal to 0, but it is equal to 1. You can think this way. 0 factorial is defined as 1 because the permutation or arrangement of 0 object, nothing for you to arrange, or not arranging anything, is considered as one way or one arrangement. So that's why 0 factorial is equal to 1. If you want to use some calculation to show that 0 factorial is equal to 1, we can use this one to help us. Since we know n factorial is equal to n times n minus 1 factorial, right? 1 factorial is equal to 1 times 1 minus 1 factorial. Okay, so 1 factorial is actually equal to, okay, I bring the 1 over here first. 1 times 1 minus 1 factorial, bring over here, it becomes dy. 1 minus 1 will be equal to 0. Okay, just copy the factorial. 0 factorial. Okay, 1 factorial is equal to 1. And 1 is equal to 1, right? So 1 divided by 1, you get 1. From here, we know that 0 factorial is actually equal to 1. Remember, 0 factorial is equal to 1, not equal to 0. So if you forget, you actually can use your calculator to help you. So how do we press factorial? 6 factorial, we can just press 6 and then followed by, you see the factorial sign here, but this is in yellow color, so you have to press shift first. Then your calculator will know that you want this factorial. Okay, so 0 factorial is equal to 1. Okay, nPn is actually equal to n factorial. Okay, let's say I have 3 digits, 1, 2, and 3. How many number of way I can arrange them? Let's say I want to use up all the digit. Every digit I can use them once without repetition. It can be 1. It can be 1, 2, 3. Or 1, 3, 2. It can be 2, 1, 3 or 2, 3, 1. And 3, 1, 2, 3, 2, 1. Total, we have how many arrangement? 1, 2, 3, 4, 5, 6. We have 6 ways to arrange them. But sometimes we have no time to list out all of this. So we need a way to get the answer faster. To get the number of ways to arrange 3 objects randomly, right? We have 3 objects, we want to use 3 of them. We can write this as 3p3. We have 3 objects, we want to use 3 of them. 3p3 is actually equal to 3 factorial. So it just means 3 times 2 times 1. So it will be 6. You see, you get the same answer. Okay, so how about let's say we have A, B, C, D. Now I have four letters. I want to arrange them, 4 of them. Every letters you can use them 1. How many way we can arrange them? Do we have time to list out all of this? We don't have time, right? So the number of way to arrange 4 of this is equal to 4p4. We have 4 objects. We want to use up all of them. 4. So 4p4 is actually equal to 4 factorial. So you can press your calculator, 4 factorial, or 4 times 3 times 2 times 1, which is equal to 24. Okay, you can press the calculator this way, 4 factorial 24 or 4p4. 4, you see NPR here, right? Press this, 4p and 4. You press equal, you get the same answer, 24. This is a way for us to get the number of ways to arrange them easily. Okay, now let's look at few questions on permutation. Find the value of each of the following. I think 4 factorial, 6 factorial should be no problem, right? Now let's try on this part C. 80 factorial. So we don't have time to write 80 times 79 times 78 times 77 and so on. So we can do it this way. Still remember, 80 factorial is actually equal to 80 times 79 factorial, right? 79 factorial, you just copy. Now we can simplify them. So the answer will be equal to 80. So you can use your calculator check. 80 factorial divided by 79 factorial. The answer will be equal to, it may be too big, so the calculator cannot show you the answer. But 80 is correct answer. 80 is an correct answer. Okay, since the calculator cannot show the answer, let me change the number become smaller so that I can use calculator to show you the answer. Let's try a small number. Let's say 8 factorial divided by 7 factorial. Try to guess, not try to guess, try to calculate. What is the answer? 8 factorial can be written at 8 times 7 factorial. 7 factorial, you just copy, simplify them, you get 8. Okay, this number not that big, I think should be no problem for the calculator to help us to get the answer. 8 factorial divided by 7 factorial. Yes, the answer is equal to 8. Okay, let me key in again this time. See whether I can get the answer or not. So 80. Okay, maybe it's too big, so the calculator cannot show us the answer. Okay, but this is the correct answer. So how about this one? D. 60 factorial times 0 factorial divided by 58 factorial. So you can pause the video, try on your own first, see whether you can get the answer. I want to simplify, I want to try to change this to something times 58 factorial so that I can simplify them like this. 60, I can change it as 60 times 59 times 58 factorial, right? 0 factorial is actually equal to 1. Copy the 58 factorial. Okay, now we can simplify this too. So just press your calculator, 60 times 59. 60 multiplied by 59. The answer is 3540. Let me show you one more. 8 factorial times 3 factorial divided by 4 factorial times 6 factorial. Okay. This we can change become 8 times 7 times 6 factorial. So 3 factorial here I just copy. 4 factorial I can change become 4 times 3 factorial, right? Then this 6 factorial I just copy. Now I can start to simplify them. 6 factorial cancel, 3 factorial cancel. 8 times 7 divided by 4. Here you can simplify further if you want. So 2 times 7 you will get 14. So the answer for this part E is 14. Okay, now let's look at these questions. Find the number of ways of arranging all the letters of the word number. So we have no time to list up all of them. So we need to use permutation method to help us to get the answer, number of ways. 1, 2, 3, 4, 5, 6. It actually means 6p6 because we need to use all of them. We have 6 letters, we need to use all of them. So 6p6. It just means 6 factorial. 6 factorial is actually equal to 6 times 5 times 4 times 3 times 2 times 1. Okay, so 6 factorial, you can use your calculator to help you. 6 factorial is equal to 720. We have 720 arrangement, 720 ways to arrange all of these letters. So if you want to know what are they, you can actually go to Google and try search for permutation generator. You can get the answer also. So let me try number. Let me key in the words first. No restriction, so means that no condition, any condition is okay. Generate 720 way. These are all the possible arrangement. Okay, all the possible arrangement are here, which is 720 way. Okay, our answer correct. Now let's go to second questions. How many 5-digit number can be formed using the digit 1, 3, 5, 7, 9? Okay, number of way, number of digit, number of 5-digit number. How many digits we have here? 1, 2, 3, 4, 5. 5. We want to use 5. We want to form 5 digits. It means that we need to use all of them. So it will be 5p5, which means 5 factorial. So 5 factorial, you can just press your calculator, or you can write one more step. 5 times 4 times 3 times 2 times 1. 5 factorial. Okay, which is equal to 120, or you can just press 5p5. You get the same answer as well, 120. Okay, without repetition. So some students start to think, what is the difference between without repetition and with repetition? This question, some students want to do it another way. So let's say you can do it this way also. We want 5 digit, right? So I just draw 5 line, 5 empty spaces here. So try to think without repetition means that every digit I only can use them one time. The first column, the first empty space here, how many digits I have to fill in here? It can be 1, 3, 5, 7, 9, right? I have 5 choices. After fill in one digit here, if the question asks you to find the number of way to arrange this all the digits here without repetition, one of them you have put it here. So means that here the choices for the second empty space will reduce 1, right? So now we have 4 choices only. After this, it will become 3, 2, and 1. They actually the same thing as this, you see? 5 times 4 times 3 times 1. 5 times 4 times 3 times 2 times 1. Some students want to do it this way. Also can. You get exactly the same answer. So if the question changes a little bit, with repetition, so the answer will be different. With repetition, it means that it can be repeated. If you want to find the number of way, it's no longer like this. Try to think how many digits we have here. 5, right? So since that it can be repeated, here still we have 5 choices. Here also same thing, 5 choices, 5 choices, 5 choices. So the answer is actually equal to 5 power 1, 2, 3, 4, 5. 5 power 5. It will be a lot since it can be repeated. 5 power 5. So the answer is 3, 1, 2, 5. Try to compare these two. This is a lot because the digit can be repeated, can be used again and again. Okay, now let's go to this question. No repetition and repetition. You can pause the video and try on your own first. Let's look at the question. How many 6-digit number can be formed using the digit 2, 3, 4, 5, 6, 7, 8, and 9 if no repetition of the digit is allowed? Number of way. How many 6-digit number? Number of 6-digit number. But this time you need to be more careful. How many digits we have here? 1, 2, 3, 4, 5, 6, 7, 8. 8 digits we have. But we only need 6 of them. It will be 8p6. So before I continuing doing, let me show you this first. Just now I told you that npn is actually equal to n factorial, right? So how about npr? This will be equal to n factorial divided by n minus r factorial. Let me give you some example. Let's say you have 4 letters, you only want 2 of them. It will be 4 factorial divided by 4 minus 2 factorial. Okay, so this will give you 4 factorial. This will give you 2 factorial. So you can press your calculator if you want to do it manually. This 4 factorial can be written as 4 times 3 times 2 factorial. The 2 factorial you just copy, then you can simplify them. Eventually you get 12. So how do we press our calculator to get this answer? 4 p 2. This is the answer. Okay. Now we are going to use this one to help us to get the number of 6-digit numbers that we can form by using 8 digit here. 8 factorial divided by 8 minus 6 factorial. Okay, so you can press your calculator 8p6, or if you do want to calculate it manually, you can do this way. X times 7 times, okay, I think this one, we don't need to write this out, we can just press our calculator. 8 factorial divided by 2 factorial. 8 factorial divided by 2 factorial, which is equal to 20160. If you don't want to press this way, you also can press 8p6. You get exactly the same answer. Okay, so this is without repetition. So how about B? We can repeat using the same digit. It can be 2, 2, 2, and so on. The digit after using it, we still can use it again. So you know the answer will be larger than this. Okay, so besides we solve using this method, some students like to use this way. We want 6 digit, right? So we just draw 6 empty spaces here. 1, 2, 3, 4, 5, 6. First empty space here, we have 8 choices. After fill in here, after we use up one of them, we left 7 choices, 6 choices, and so on. You try to press your calculator. 8 times 7 times 6 times 5 times 4 times 3. You get exactly the same answer. Let's try. 8 times 7 times 6 times 5 times 4 times 3. 20160. Okay, this is another way that we can use to solve this type of question. Now let's look at part B. This time we can repeat using the same digit. Number of 6-digit number. So try to think, how do we solve it? We can use this method. We no longer use 8p6. We are going to use this method. 1, 2, 3, 4, 5, 6. First column offers empty space. How many choices we have here? 8. Since it can be repeated, right? So here we also have 8 choices. Do the same thing for the rest. Every empty space we have 8 choices. So it will be 8 power 1, 2, 3, 4, 5, 6. Press your calculator, it will be very large. 262144. 262144. Okay, so this is the answer for part B. When you solve this type of quotient, you need to be more careful. With repetition and without repetition, we need to solve them differently. Their answers are different. Okay, for this video, I stop here first. See you in the next video. Bye bye.